Our objective for today, can factor polynomials completely. Just read together. 1, 2, 3. So we're still in factoring. I'm starting with polynomials on this objective, but we're also looking at quadratic trinomials. We don't need fair models for either one because we already know the definition of all this, right? So you know the definition of polynomials, please. Okay. Enrique, definition. Monomial or sum or difference of monomials. That is correct. And of course, we don't need a fair model for quadratic trinomials because you know the definition. Tell your neighbor the definition.
An expression with more terms. No. Let me get real quick. No. I'll find you one thing.
Oh, expecting a 3-term period
Okay. Leslie, go.
I know this.
She's got it. Okay, Tanner, go. That is correct. It should look something like this. Yes? Now, and what are the, for this one, what are the most important numbers that you can remember this one by? 2 and 3? No, 2 and 3. Let's go. Also, we know steps by now. Tell your neighbor the first 2 steps that we always check for. And GCF. From there, when we go to step 3, of course, we do the Power Rangers and so on and so forth. For today, we're going to do a practice of some of the things that we've seen. And then I'm going to show you some, I don't want to say shortcuts, I just want to tell you a different way of factoring that is faster. But we haven't practiced it because I want you to continue practicing by grouping because that's one thing that we need to practice, yes? Yes. But some of these can be factored very easily, okay? So without further ado, copy this one, please. Example 1. Mr. Q. Okay, thank you. All right, bye-bye. Wrong number. Daniel B. to the office, please. Yeah, take your stuff. Should be almost done with that one. That says factor, right? Are you done?
You the problem.
Oh, no, I'm sorry.
All right, factors for this one. Yeah, I said factor, right? No.
Okay.
You got it? Okay, let me go over this. Here we go. Standard form, GCF, Power Rangers, 12, 8. Some factors of 12 that add up to 8, 2, 6, x squared plus 2x plus 6x plus 12. Group, x plus 2, plus 6, x plus 2, x plus 2, x plus 6. These are my factors. Number 2, stay focused because it's going to go really fast. This is just a full review of everything we've seen. Number 2, copy and factor. X squared minus 8x plus 15. 40 seconds. Standard form, GCF none other than 1. Power Rangers, we got 15, -8. Product of 15 that add up to -8, 3 and 5, and both of them are negative. X squared minus 3x minus 5x plus 15. Group. GCF is x, we're left with x minus 3. GCF -5, we're left with x minus 3. Factors are x minus 3 and x minus 5. These are my factors. Hands if you got that. Okay, number 3. Copy that one. X squared plus x minus 20. Seconds. Yeah, if you're taking longer than that, that means that you haven't been doing your home plate. Your noodle's not taking all the processes. Should be done by now. Power Rangers, -20, 1. Factors of 20 that add or subtract to give us 1, 4, and 5. But this tells us that one of them is negative. Now look up, please. This bottom one always tells us the sign of the biggest of the two numbers. What is the sign of 5? Positive, so that means the negative is that one. X squared minus 4x plus 5x minus 20. Group x, x minus 4, 5, x minus 4, x minus 4 times x plus 5. These are my factors. And we got that? Okay, number 4. Yeah, we're jamming. Here we go. X squared minus 3x minus 18. Copy and factor, please. Go. All right, here it goes. Standard form, yes. GCF other than 1, no. Power Rangers, -18 is our product. -3 is our sum. Factors of 18 that if you add or subtract give us 3. That's 3 and 6. This tells us that one of them is negative. But this tells us the sign of the biggest number. So which one's the negative? 6. So therefore, x squared plus 3x minus 6x minus 18. Group, and GCF here is x plus 3. GCF here is -6, x plus 3. So our factors are x plus 3, x minus 6, and these are my factors. Hands if you got that. Okay, good. So far so good? Yeah? Okay. So before I move on, look up please. I wanted to first highlight some patterns. Yeah? See if you already, I already talked about some of these, but I just wanted to highlight them to make sure that you are understanding what we're looking at. Here it goes. First pattern. Right now I'm only looking at the last two terms. The last two terms are positive. What are the numbers in each of the factors? So how can we generalize the idea? That if the last two terms are positive, the quadratic trinomial, both numbers of the factors are. Does that make sense? Okay, next. If the middle term is negative, both of the numbers in the factors are. That's a good generalized idea, yes? Yeah. Yeah, I'll be right with you. Gavin. I'll get to that. Okay. Next. Right now I'm just generalizing stuff that we see. Here it goes. Next. When the last term is negative, how can we generalize that idea?
The first one will be negative.
What if I switch these?
The last one.
One of the numbers.
One of the numbers has to be, but which number?
The smallest number.
The smallest factor is negative. Here it goes again. If the last term is negative, the smallest factor of the two is negative. And the last one. If the middle and the last term are negative, generalize the idea. Tell your neighbor, please. So if both of them are negative, the middle and the last term, the largest of the two factors is negative. So things to see to make it go a little bit faster in your noodle so that you don't have to be thinking that much, okay? Number 5, copy this, example Q. Okay. 2x squared plus 11x plus 5. Use it in standard form. Does it have a GCF? It does? No. Power rangers. What goes on top? Close. 10. Tell your neighbor why. You don't forget to multiply. Don't forget to multiply the leading coefficient times the last term. Okay? What goes in the bottom? 11. Therefore, what factors of 10 add up to 11? 1 and 10. All right. Let me rewrite this. 2x squared. But instead of 11, what do I write? 1x, 10x, and I bring down the last term, which is plus 5. Let's group the first two. Let's group the last two. GCF here is x. We're left with 2x plus 1. GCF here is 5, and we're left with 2x plus 1. My factors are 2x plus 1 and x plus 5. These are my factors. All right? Show me your parents how comfortable you are up to right there. Okay. All right. So the next part is the most important part of the lesson that I wanted to show you. All right, here we go. Ready? Here it goes. Look up to the screen. So, like everything has different patterns and different methods. I've been showing you which method of factoring by grouping. Is that correct? Is it lengthy? Is it long? Yes. But is it necessary? Yes, because you need this to be in your noodle so that it stays hibernating for a long time so that when you get to algebra 2, you can recall it and it's in there. Does that make sense? So check this out. However, some of you already made the observation. I'm going to bring it up so it can be as obvious as obvious. Let's say I didn't use this method. And I went from here to here. There it goes again. Here goes another. Again, I'll cover this up, and I can go from here to there. Okay? Yes. Okay, so that works with these, look up, these simple ones, right? What happens when we get to this one? You can't do that unless you do this. Look up. Watch. Watch. Ready? Can we simplify this one? What is this one in simplified form? No.
No.
Yeah, you missed the main part of the whole thing. All right.
No, I get it.
So look up, people. This method for these, this has a particular name. This was a method that a math teacher in California came up with back in the 80s. There's a movie out. I recommend it. You guys watch it with your parents, called Stand and Deliver. The teacher's name was Jaime Escalante.
I watched that.
This is known as the Escalante method. This one right here. This one we just did right now. Okay? So, since we saw a couple of the other ones, okay, let's do another one of these to see if the method, Escalante method, works with this kind. Example, supercube. Copy this. 3x squared plus 7x plus 2. Is it in standard form? Does it have GCF other than 1? No. Therefore, Power Rangers. What goes on top? 6. What goes underneath? 7. Factors of 6 that add up to 7, 1, and 6. Therefore, from there we can get our factors. What do we need? The leading coefficient, right? So my factors are?
3x plus 1, and then 1.
These are my factors. Once again, what is this one called? Escalante method. So once again, am I asking you to do these methods? No, I'm showing you different methods to factor, but which is the method that I always want you to show me? Grouping method. Yes? Everybody with me? You're saying, I know, Mr. Q, but I like these because they're faster. I know, I get it. But if you do the easier and faster method, guess what's going to happen with this when you get down to the 2? You're not going to have it. Okay? Therefore, we good up to right there? Okay, let's crank it up. Copy this one. Example number 5. 2x squared plus 12x plus 10. Factor that. No, you may not do it with shortcuts. Do this one the long way.
Oh, Mr. Q.
Yeah, do it using grouping method, and then from there in your noodle, use whatever shortcut that you want and see if it works. Is it in standard form? Does it have GCF?
Yeah, it does.
It does. It's a 2. We're left with x squared plus 6x plus 5. Therefore, Power Rangers. 5, 6. Factors of 5 that add up to 6. 1 and 5. Let's rewrite this. X squared plus, instead of 6x, we're going to write what? 1x plus 5x plus 5. Let's group. GCF here is x. We're left with x plus 1. GCF here is what? 5. We're left with x plus 1. My factors are x plus 1, x plus 5, and don't forget your BFF, which is 2. These are my factors. I want to see this. Do you play basketball? You play what? Okay, so if I said, okay, you're on the team, I don't want you to practice all 3 months, and I want you to start on the first game, and all I want you to do is shoot threes. What are you going to do? You're not going to make them. Exactly. You got to practice muscle memory so it can be there, automatic. All right, let's do another one. Copy this one. Example 6. There's some right there, right in front of you.
Yeah, well, we can use that. I always get that paper. No, I have the back. Come on. Put it back. Save the earth. It's already dead.
Oh my goodness, focus, my goodness. Negative 4x squared minus 34x minus 42. There is Cecilia. Who's got the GCF? It's not 4. It's not 2. Negative 2. 2x squared plus 17x plus 21. Power Rangers. What goes on top?
No, 42.
2 times 21 is 42. 17 down here. Factors of 42 that add up to 17. 6 plus 7 is 17?
I'm thinking of 12.
That's smaller right there. I'm sorry.
Nice. Very good. 3 times 14. Yes? Okay, so we rewrite this. 2x to the second, and then plus 3x plus 14x plus 21. And then we group. So this is x, 2x plus 3. This is 7. 2x plus 3. So my factors are 2x plus 3 times x plus 7. Don't forget the BFF. Negative 2. And these are my factors. And if you got that, okay, good. We good? Yeah? Last one. Yeah, number 7.
Okay, I have this like tiny spacer.
There you go.
It's like Jammy Jam.
It's the last one. Number 7. Bam! Let's go. Example 7a. X squared minus 14x plus 49. B. 81x squared plus 90x plus 25. C. 9x squared minus 6x plus 4. And D. 9x squared minus 36. I want you to start with letter B. No, copy all of them, but I'm saying start with B. Exactly, B for bam. 81 times 25 is 2025. It is.
What is it actually?
Yeah.
81 times 25?
2025.
Because he's like a mad genius. Yeah, that's right. Life? Life.
No.
Be nice, my God.
Okay, blind.
Doesn't respect people in class.
What's that? Hmm? 2025.
Oh, we can do can we do the circuit? Nine? What time was nine? What time was 10,025 divided by? No. 45 times 8.
It's like part of the problem. It's like
5 times 3.
Alright, let's see. Look up. Here it goes. Power Rangers, 81 times 25 is 2025. That's our product. 90 is our sum. Find all the factors of 2025. 1 times 2025. It'll take us forever, right? So that should be a red flag for us to try and think of something else that we can do. Square root of the first, 9x. Square root of the last, 5. Let's see if it's a perfect square. What is 9x times 5? 45 times 2, 90. So then we use this one. Squared. These are my factors. Okay. Want you to go to A. See if you can do A similar to that one. No, A, not C. A. Who's done with A? Who used Power Rangers? Who used square roots? Square roots also works. Let's see. Square root of the first, x. Square root of the last, 7. What is x times 7? 7x. Double that, 14 minus squared. These are my factors. Number 7C.
Oh, my back.
Square root of the first, 3x. Square root of the last. No, what? Square root of the last. What is 3x times 2? 6 times 2? Is that this? So it doesn't work. Therefore, this is not a perfect square. Yes. Then you use a negative, like here. Okay, square root of the first, x. Square root of the last, 7. 7 times x, 7x. Double that, is that 14? Yes, use the negative sign and put it there. Oh, we're not done with this one. Here we go. Power Rangers. What goes on top?
36.
What goes on the bottom?
Negative 6.
What factors of 36 give us negative 30? Negative 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6. Which one of those gives us this? 4 and 9 gives us negative 6? No. 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 And no, not factorable.
Not supportable.
And the last one. Let's see. Angie, what can we do with this one? Square root. Square root of the first. 3x. Square root of the last. 6. Is this a difference of squares? So this is 3x minus 6 and 3x plus 6. These are my factors. Home plate for tonight is on page 557. All only. It's a full review because tomorrow we're moving on. Yes. As soon as the bell rings, have a good one, guys. Enjoy your home plate. See you guys tomorrow. Bye. I'll give you guys 10 seconds free time.